Hello all. Now today we will start with JFG problem and we'll do this problem statement check for the children sum property in a binary tree. So let us first check like what is the problem statement given. So one binary tree will be there and we have to check if this contain like children sum property. So, what is this property is like every node is the sum of its left child and right child. Okay, so here, like example one is given 35. Okay, so left child is 20 and right child is 15. So, 20 plus 15 is 35. So, yeah, this is true. Again, we will check with the next node, this 20. Again, we will go to the left and right. We will check that 15 plus 5 is 20. So, yeah, again, it is true. Again, we will go over here to the next node. So here also 10 plus 5 is true, 15. So yeah, overall the tree contains this property. So we will give an output as 1 and we will say that yes, this property is there. Now in example 2 that is given, now let's see it here. So here this is output is 0. So let's check why it is 0. So the first very node is given as 1 and when we will check with the left and right child, so it will be like 4 plus 3. It is coming as 7, but that is not equal to the root value. So at the very first check only, we got this as a false condition. So immediately we will say that it is not correct. Okay. So here we will give the output as 0. So because in the very first condition we saw that uh, this property is not there. So we will not check further. Okay, and one corner condition we have seen here is like when it is the leaf node, so this property is not checked for it because all the left and right child is zero null containing. So this we will not check for the leaf node. This is only for the interior nodes, okay, which have some value. Okay, so let's start coding it. So yeah, only mm, this root node is given. So we have to traverse the tree, and for every node we will check if the summation of the nodes is equal to that node value. So if this property is contained, that means it's this property is there in each and every node. Okay, then we will say that yes, this children sum property is there in the binary tree. Now let's start with the root node. So I have been given a node named as root. Okay, so first what we will do, like this value is given as 35. Okay, we will go left and we will go right, like we will travel and we will check for the sum. So since for this we are checking, so let's take a boolean value so that we can check. Okay, boolean value so that we can keep a counter like a flag so that we can check. Okay, flag. Okay, and we will travel to this tree, like going to the left and then right, and then we will see which if the sum is correct. So we will make a separate function travel, and we will pass this route because we just have this route and through this we need to travel. And then if this condition, suppose we have traveled all the nodes and the condition is true for everyone, so we will be passing since integer it's int return type, so we will pass as 1 if it's correct, else we will return 0. Okay, so if my boolean value, that is flag, is true, okay, so it will come as a true. So just pass if condition flag, so if it will be true it will enter this for if loop, else not. Okay, so if this flag will be true, then it will return. So we will return return as 1, else we will return 0. Okay. Now okay, this return 0 is outside this if loop. Okay, so here if my flag will be true, then we will return 1, else return 0. Okay, so yeah, now the condition is there that we have to see how we will travel to this tree and how we will check for this summation of left and right child. Okay, so we will write the travel function that we have used. So this travel function, we will define it over here. This is a user defined function. Okay, so yeah, we will define, and yeah, let's start it. So public it will be, and we have to give static. Okay, since it is a static function over here, so we have also have to use, okay, you can't leave this, you have to use static over here as well. Okay, so static, and my return type will be boolean. Okay, so I will return boolean values, so we have to use boolean. Okay, my function name is travel, and here root, so I will, it is node root. I will receive the value that I am passing root, I will receive this value over here, so I'm keeping the same name. You can also use a different name, since this is like actual parameter and this is a formal parameter, so you can even use a different name, but for I'm using the same. Okay, so now I am having this route. Okay, so we will travel to this left and right. Okay, before that we have to see what is the corner condition, like on what cases we will directly pass the this function, we will not further check. So you can see when it is a leaf node. Okay, then we will not travel left and right because both values null. Why we will waste time? So that is a corner condition, so we need to check that. And suppose if you have been given a binary tree which don't have any value, okay, so that time also when the root value is null, then you will not waste time checking it, okay, and traversing left and right, because it has only value null. So we'll directly pass that corner condition. Okay, if my root is itself as null, okay, or my both the child, okay, root dot left is null, and because I'm checking for both child, okay, and root dot right is null, both the child is null, so I will directly return this value, will not check further, so will directly return true. Okay, will not check further for this. Okay, now now, if this condition is not there, okay, like I am in the very first root node 35. So here I will go to the left and right, and I will sum it. Okay, for that I can use a variable. I can go left, I can go right, sum it, and then I can check with the root. Okay, so I will take an integer k that I will initialize with 0, and if my root dot, okay, root dot left, first I will check if it's not null. If it's not null, okay, then I will go inside and I will, okay, not written, okay, I will sum it to the k. Okay, then root dot left dot data. Okay, so here I will, yeah, yeah, see this one statement is like k is equal to, see, I will write and show it, this will be like k is equal to k plus something. Okay, something, anything, you can write it over here. So this is like, shortcut. Okay, you don't have to write k is equal to k plus 1, you just it can be mm, written like this. Okay, so this is one thing. And root dot left dot data. Okay, so here you can see the description that is given. So data, in the data place key is stored. Key is like a value, where the tree value is stored is, that variable is referred as a data. Okay, so I'm using data variable over here. Okay, okay, so here the same way I will check for my right. Okay, right node. Okay, so root dot right variable. If this is not equal to null, I will sum it. Okay, k is equal to, okay, k is equal to k plus root dot right dot data. Yeah, this is done. So now I will check it. Okay, so here I will check if this is true. Okay, I will check, okay, if my root dot data, okay, if my root dot data, that is 35, is equal to k. Okay, then I will check with, if this is correct, then I will go to my left subtree. Okay, and then I will go to my right subtree. Okay, so I will check this in a single statement using recursion. Okay, so if this is true, so I'm using AND operator. If this is true, then I will go to my travel. Okay, travel root dot left. Okay, and if this is also true, okay, then I will go to my travel root dot right. Okay, so here I can check this in a single statement, and okay, this is done. So the meaning of this is, like, the way I have checked for this thing, this set of nodes, the same way I will go to the left root of root dot left, and again I will check the same. Okay, then again I will go to my root dot right, again I'll go to the root dot right, and again I will check for this set of three. Okay, so this is the recursion how it will be taken up. And here, okay, instead of giving if, I can directly return, because this will give me a true or false value, uh, directly boolean value, so I can pass this. Okay, so here it's done, and let's check it, if we have any compilation error. Okay, so yeah, we have in 148 line, yeah, we are missing just identifier name error, so we'll correct it. Let's check it again. So yeah, it is running just for one test case. Let's check for all other test cases. Okay, so we are not missing out any of the corner condition. So here you can see 1,120 test cases are there. It should pass all, so that my all the test cases are passed, and this program is like handling all the things. Okay, so yeah, that's it for this problem. Try solving the same type of problem where we are traversing the left and right, like here that we have done. Try solving the similar problems, you will get it. And yeah, we'll get back with the next problem. Thank you.